Good afternoon, good morning, good evening. This is Andrew Turner, founder and host of the G&T Sessions podcast. And today we have an amazing guest, Mr. Patrick Bangert. How are you, Patrick?
Hi, Andrew. I'm doing very well. Thank you for inviting me. I work for Samsung SDS. I'm the VP for Artificial Intelligence, and I'm here to represent the field.
Very good. It looks like you're representing a very nice picture at the back of from somewhere not in London where I am. Obviously, I'm sat on the beach in London. You've got lots of beaches in London, not. But it sounds
Yes,
like, where are you joining us from today?
It's not the Tower Bridge. It is the Golden Gate Bridge behind me. It's in San Francisco, even though our offices are in San Jose.
Nice, nice. I'm sure it's very sunny over there.
It is always very sunny over here, yes.
So thank you for coming on the show. It's a pleasure to meet you again. I know that we spoke recently because you were talking about some of the things that are potentially coming up in the future. And as you did in your brief intro, which I know we'll come back to in a second, you're involved in this thing called AI, artificial intelligence, which sounds very mystical and for some people. I know some people know what it's about. And obviously, I think you're going to tell us a bit about that today. But what gets you up in the morning these days? What kicks you out of bed in the morning? Anything special?
Breakfast gets me up in the morning. I wake up hungry, and then beyond that, it's my Outlook calendar that regulates my life with meetings, discussing with colleagues, with customers, with users of AI, panels like this, where I get to discuss the latest ideas and advance the field. But what really excites me, of course, is the evolution of technology in the artificial intelligence space. The pace of development is quite fast these days. New innovations are coming out virtually on a weekly basis. And then the questions are, is this advancement for real? Is it significant? Shall we use it? Shall we ignore it? What can we do to contribute to the advancement in the field? And those discussions are happening every few days.
And I suppose it's this thing about, is it tech for good as well? Because I know there's the yin and the yang these days about, I remember watching, like if you watch the Terminator films, many years ago.
Yes.
And then, Rise of the Machines. And then actually, it's actually here. And you look at, you rewatch Terminator, you go, I can recognize some of this stuff. It's like, what's really going on here? So yeah. It just shows, I don't know whether Hollywood actually had a kind of a peek into the future, or they were just kind of, they were spot on by their predictions. I don't know.
I think not. So I would say on the one hand, if you're worried about AI taking over the world, don't be, because it's already happened.
Oh, wow. Okay.
A number of examples. We don't really watch TV anymore. We watch programs like Netflix. They tell you what to watch, and you watch what they tell you. You want to find something, you go to Google. The result is an AI list of things to go to. You visit a website of a major retailer. There's a chat bot that comes up at the bottom. You can ask your questions. You buy an airline ticket, you buy a hotel room, you search where to go for your travel. All of these recommender systems are AI based. You talk with your mobile phone to get it to recognize your speech or do what you say. All of this is AI. You will be encountering some kind of AI model, maybe 10 to 20 times every single day of your life.
Wow.
These days. So AI has in fact taken over the world. So that's the one side of the story. The other side of the story, do we have a Terminator? Well, no. If you think of an artificial intelligence as a Terminator-like entity that has cognition similar to a human being, we are very, very far away from that state of technology, and that will not be coming anytime soon. I would say during my lifetime, this is unrealistic, entirely unrealistic to achieve, because on the one hand, the mathematical technologies we have access to today are far more simplistic. On the other hand, the financial investment by all the commercial companies out there that push the field are towards extremely specialized applications that do single things. The most complicated innovation that's ongoing currently is autonomous driving. And that has taken perhaps about a decade already, and we're not quite there yet even. And this is just teaching a computer to drive a car. This is something that every teenager learns in a month. Imagine teaching AI to do something actually complicated. We're not there.
Right. So what, I mean, so it's an interesting point. Like, so what you're saying is that my very obviously, but not great example, obviously, of just trying to relate to kind of day-to-day work. I suppose this thing about the Terminator film, the Arnold Schwarzenegger, I'll be back. Hasta la vista, baby. What you're saying is that you believe that 30, 40, 50, 60, it's kind of like it's in the kind of the multiple decades away, that type of scenario, that type of use case, or do you think it will ever come to pass that will happen? Or
yeah, so the Terminator example is perfect. I know that a lot of people are worried about this. A lot of people, among the public are worried about this, as well as, research scientists. I know that a group around Stephen Hawking, a few years ago, they submitted a formal kind of warning letter to the governments of the world. If you don't watch out, the Terminator will take over the world, in the next few years. For those of us who are in the field of artificial intelligence, we know it's not close at all.
Okay.
I believe it will not happen during my lifetime. I think personally is my opinion that it will probably not happen at all. There are people who disagree with me, and one can have a very nice argument about this, but the timeline basically relies on inventing things that don't exist yet.
Okay.
And
so there's a gestation period to that. There's going to be a timeline to get to that point of maturity. Yeah.
Yes, we will have to make several breakthrough innovations. And at this point, it's unclear whether that's a matter of time or whether those are fundamentally impossible.
Interesting. So there is some kind of futurology stuff where they were painting a picture with that series of films, where actually it was literally white space. It was literally kind of, they were going past the scientific research that had already been done. They were kind of extrapolating what they believe could be a future scenario.
It's called Hollywood.
Okay. Everybody's in Hollywood now. You see, we're on the G&T Sessions podcast, right? Which is, you can get your own TV channel now. Yeah, that's what we're doing. We're creating content, live here today.
Absolutely.
So yeah, I know you started with, your kind of, the kind of thing you're doing, the organization you're working for now. So, what kind of things are you working on? What kind of projects are you working on? Because you're working for a very, very prestigious organization, Samsung. I used to deal with them a lot, because I've spent the last 20 years in the telco industry, in the mobile industry. So I remember my quick story for all the audience is that I was actually, when I was at Tesco Mobile, we had a supply issue with some of the particular Nokia handsets. So you can imagine how long ago this was. It's like in the 2000s, yeah. And the managing director of Nokia UK he was a Finnish guy, obviously not surprisingly, because obviously a Finnish company. I think it's Mats, it was called. I met him in one of our big stores in Tesco in London, one of the big hypermarket formats. And I said, okay, Mats, you see this fixture here with all these different phones on here, right? You see there's these ones that are out of stock, yeah? If we don't get some stock from Nokia in the next few weeks, there will become Samsung handsets on this fixture, yeah? So he immediately made a call. He said, okay, please redirect all the stock from Carphone Warehouse to Tesco. So it's amazingly, but I had a really good relationship with the Samsung guys. So there was a guy called Mark Mitchison, who was the EVP of Samsung UK and Ireland. He used to take me to the football match because you sponsored Chelsea. You remember Chelsea, the Chelsea Football Club. So, but he was a great, fantastic guy. He was ex-Nokia and then joined Samsung to help them set up their business in the UK. And they were phenomenally successful, you know, because, so, you know, it's, I mean, so you're working for I suppose, I don't know how you describe it. Samsung, it's like a conglomerate. And so it's like, it's because you're not just involved, you're involved in multiple different businesses in Samsung. Is that right?
Right. So Samsung brand has approximately 20 legal entities underneath it.
Wow.
There is Samsung Electronics, which makes the mobile phones. There is Samsung Semiconductor that makes the chips that go inside the phones. And there's Samsung Display that makes the monitors and TVs. And,
right.
You can even buy a Samsung washing machine.
Yeah. The white goods, yeah.
Right. So we're represented in a number of verticals. And one of those companies is Samsung SDS. That's the company I work for.
Okay.
And that's the IT organization.
Okay.
So we run the data centers. We write the software. So we do all of that IT stuff for all the other Samsung affiliate companies, as well as for outside companies as well.
Oh wow, fantastic! So you kind of built your own. You help the sister companies, but you also do that externally as well. It's not just purely internal work.
Right.
And what types of things would you do? You'd set up what would you offer in that type of SDS? If I was a customer, for example, say I was back at Tesco, what would you come and offer Tesco, for example? You could do what?
Well, the core of the business is running data centers.
Oh, okay.
So it's comparable to Amazon AWS, Amazon Web Services, or the Google Cloud.
Oh wow!
Yeah. So that's the core offering, and then of course on top of the core offering of the hardware technologies that run your software, we of course offer the software as well. Mm-hmm. And so my department within SDS deals with all the artificial intelligence applications.
Okay.
You know, if you're going to host your data on a data center, do you need to, for example, forecast something? That would be an AI model.
Yeah.
Consumer demand, or you know, the evolution of some
supply chain.
Yeah. Do you need to optimize your supply chain? You need to track where are the packages going? Where should they be going instead? In which order should the driver go to the sites and whatnot? So all of those AI type applications could then be dealt with by that department.
You could have helped Nokia. You see, you could have helped Nokia on that reallocation of stock to Tesco.
That's right.
So automatically, you should prioritize your stock to send it to Tesco. Forget Carrefour Warehouse.
Yeah.
So
these days, in terms of,
you find lots of different applications, different use cases where you provide the infrastructure from data through to how you compute, etc., like Google Cloud, GCP, etc. But then you offer applications on top of that as well. Is that right? Yeah.
Right. So we provide two kinds of infrastructure. The one is the hardware infrastructure, and for the artificial intelligence, we have also a piece of infrastructure, if you will. It accelerates the training of AI models. So if you're in the field, the major stumbling block to AI models is the training time. If you're looking at models that have a large amount of data, or the models themselves are large, then you might need months and months of training time.
Right.
And we have a program in place called the AI Accelerator that reduces that from months to hours.
Oh, wow.
And that's nice, of course, that it can make things faster. But through making it faster, it enables a number of things that you wouldn't have been able to do before. So for example, you can use artificial intelligence to decide which type of model is best for you. You can use it to synthetically create combinations of existing data to better represent the situation, feature generation. You can use it to tune the parameters of the model as well as the algorithm so that you can get to a better result. And of course, each one of these things requires several training loops to be executed.
Mm-hmm.
And if that training loop is very, very slow, like 2 months, then of course it's impossible to do these things. But if I can bring it down to an hour or two, then it's an enabling technology that allows you to do these things. And then you can actually get to a better model. So typically you might get a 10%, 20% performance improvement in terms of accuracy of your model by doing these automated ML type things. And that's what gets enabled by having a hardware cluster combined with this distributed training software as well. So
and
that's the core of our offering.
Is that unique to you, the training model? Is that what you're finding?
That's right.
Fantastic. That's really good. Yeah, because I worked with a machine learning company a few years ago in Silicon Valley, Mountain View, just near where you are. And that was one of the biggest challenges we had. We had it was a kind of Hadoop stroke cloud-based data catalog. And obviously, you bring all the data into the platform. You then get data stewards to curate it, but then obviously the accuracy of the model was then you have to feed data into it, and it's not like you go like that. You flick a switch and it's all done. It took months. It could take a year to get that data to be. So it's a real big issue in adoption. Yeah, because the nirvana was, oh yeah, we're all going to be using machine learning, and then people realize the magnitude of the task. It's not just about putting the thing on the floor and feeding it the first set of data. You've got to keep feeding it, and then you obviously get better and better results. So I think that's the kind of the educational thing I found doing that with customers like large banks, and even we did some work with a very large aeroplane manufacturer in Toulouse in France. You can probably guess who they are.
Right.
And they were obviously codifying their whole data management across their whole how to manufacture a plane. So it was pretty complex. Interesting.
Yes, absolutely. It's a very important point that artificial intelligence is not pressing a button and waiting for a fantastic new reality to take place. You have to work at it. And the major work is in feeding the data. You first have to get the data. You have to make sure that it's cleaned, that it's accurate, that it represents the situation that you want the AI to learn about. All that is work. Then you need to actually execute the training itself, which might take a long time. Then you have to check the results to make sure that it's really accurate.
Yeah.
So it's really like putting a child through school. Yeah. Yes, you have to drive it to school. You have to pick it up from school. You have to do homework together with it after it comes back from school, and then occasionally the exams will not be so good, and then you have to push it a little harder. Machine learning is the same way, and it may take some time.
Yeah. Keep working on it.
Yeah.
So, I mean, obviously, this is a G&T Sessions podcast. We're talking about growth and technology, and thank you for sharing that stuff about AI. I think people who listen to this podcast will learn something, even just by the first few minutes of what you've talked about. It's fascinating. So, in your personal G, obviously now you've got a great, interesting role. You're looking at the kind of really, really interesting, high impacting pieces of work with what you're doing at Samsung. What was Patrick before that? What was your? I talk about this concept called peaks and valleys. Yeah. So people, peaks where they've had a goal and achieved it, and then valleys where they've kind of maybe not quite got there and learned something out the back of that. Is there something you can share around your backstory before? What was Patrick before Samsung?
Absolutely. So as a child, I was always very much interested in how the physical world works. So it was clear to me early on that I wanted to study physics. So I went to University College London to take a physics degree. And one of the messages that came across in, I would say, virtually every lecture I ever got was the only thing worthwhile doing with your career is to become a research professor.
Well, that was their recommendation.
That was the recommendation, yes. It wasn't always spelt out, and said directly, but this was at least the subliminal message throughout.
Okay.
And so, okay, what does one do? One does a PhD. Okay. I had figured out that experiments are not my thing, so I went into theoretical physics in the United Kingdom. That's done in the mathematics department. So I went to the mathematics department to do my PhD. And the messaging continued along the same sort of lines. So of course, what did I do? As I finished, I applied for professorships, and I got one.
All right.
So yeah. So I went to
What,
Germany.
at UCL or?
No, it was in Germany at Jacobs University in Bremen, the north of Germany.
Okay.
So there I was hired to be an applied mathematician, and I, was a professor there for 3 years. And then finally, I'm a slow learner like this. I discovered as I had the job that finally it is not what they advertised it to be.
All right. Okay.
And that in order to apply some applied mathematics, you need to actually exit the academic sphere and enter the commercial sphere. So that was kind of peak and valley. I had the career goal, I achieved the career goal, and I found out that it wasn't really what I expected.
Okay. Okay.
So I decided to leave academia and to start a startup.
Good.
So
All right.
I got involved with some people to take what I had been doing as research, doing PhD and professorship, and bring that to the commercial world. So we took machine learning primarily in the sense of forecasting time series, and we went to the chemicals and oil and gas industry and said, hey, we can do predictive maintenance. So just briefly, predictive maintenance focuses on equipment, large equipment. So you might be thinking about gas turbines, steam turbine pumps that might fail.
Yeah.
And so the predictor is supposed to basically tell you, hey, watch out, next week this machine will fail for such and such reason. Hopefully then you can power it down, affect the repair before it fails. And why is that useful? It saves the collateral damage.
Yeah.
When a piece of equipment breaks, it breaks many other things as well, possibly even people.
Yeah.
And to prevent that, you want to switch it off before. So that's the use case that we pushed for a number of years. So I've been through the startup journey, and there are definitely many highs and lows with that.
Peaks and valleys.
As you win the projects, that's a high. Then oftentimes it works. Of course, that's fantastic. You can celebrate those. But then every once in a while, you don't get the deals, and you're in dire straits financially, or people leave, and that brings problems with it.
Yeah, I spent a bit of time with working after I left Tesco. I did some work for BG Group in Reading, and obviously worldwide. So they're now part of Shell, the upstream part of Shell. And I mean, they operate in 28 countries, and big in Brazil, big in Australia. And the whole MRO process, which is kind of, I presume, the area where you were working, maintenance, repair, and overhaul. I mean, just the asset list for all these different operations across the world is mind blowing. And I was working in the procurement team because I was obviously working in procurement, part of my job in Tesco, and literally just having the ability to understand from a data point of view what was, for example, Bill Nahill, who was the chief procurement officer. He just wanted to understand, right, okay, who are we buying stuff from? What we're buying, how much are we spending? Like simple questions like that. And because of the whole manifestation of how such a big operation, it took a long time to get our arms around that. So it's a very complex type of business and very at scale. So what was your takeaway from the startup experience? Obviously you're not there now, but what was the kind of is there some examples of peaks and valleys you would say from that startup experience? I mean, would you do it again, for example, or is that?
I would do it again. I would do it differently.
Right.
So I think, to all those of you out there who are thinking of becoming a startup entrepreneur, I think the two most important things to watch out for is, who do you partner with? Who are
Right.
your co-founders?
Yeah.
And who provides the money?
Okay.
So I think it's important to have co-founders. Doing it completely on your own is a very difficult task.
Mm-hmm.
But those co-founders really need to have a very similar kind of motivation and energy to you. If at some point, 6 months or 1 year into starting it, and everybody is in with all they have, then the co-founder says, "Oh, I don't want this anymore."
Mm-hmm.
Then you might be looking at dire straits at that point. So it's very important to very carefully examine your co-founders, that they in fact have the skills, the motivation that they need to. Particularly those people that are going to be responsible for selling, because I would say 90%, maybe 95% of your success doesn't depend on whatever product or service you have, but it depends on selling it. So if you're thinking like the typical German, I'm German, right? So that the typical way to approach business would be create the product, perfect the product, certify the product, perfect it a little more, get it certified again, and then attempt to sell it.
Right.
The American way of doing it is to think about the product, sell it, and then hurriedly make it.
Mm.
Commercially speaking, that is, of course, far more successful. So depending on where you are and your co-founders are, you need to choose your path. So the second aspect is money. The standard American way, of course, is the first thing you do is you go to a venture capitalist and you get millions upon millions of dollars to fund creating the product and marketing it. So the risk to the entrepreneur is minimal, but then also you have to give up shares. The standard European way is to just do it in your garage at zero to no cost until you're almost bankrupt, and then hope that you have something good enough. So somewhere in between those two is probably the best way to approach this, but it needs some thinking about. So those are the two sort of big takeaways.
Yes, I think very, very interesting. Thank you for sharing that. It's fantastic, fascinating. So what you're saying is about your founding team is make sure you do whether you're a technical founder or you're a business founder, because there's that usual kind of combination, isn't there? Is who you, because the analogy is it is like getting married. Yeah, you literally it's it's a very serious commitment, and you're going to go through lots of roller coaster ride, and making sure you've got the right connection and when times are going good, that's great. But obviously, when times are challenging, the core of the person is in the right place. Yeah,
absolutely.
And then on the thing about the funding side, I think that's fascinating comments as well, because obviously there's been a fashion over the last 5, 10, 20 years, 15 years, probably 20 years of, the default was, go to the VCs, go to private equity, get to the that capital raising. But what's the capitalization you should have? Some people I think have overcapitalized, some people have undercapitalized. How do you right size that? It is a big dilemma. Is also when you see the level of dilution expectation as well with these types of organizations that could help you. You've got to be careful, otherwise you get in a position where you've got some challenging positions to have. If you don't come on numbers and stuff like that, it gets a bit messy. So
right, absolutely. And the question under or over capitalized has to do with your priorities. And I think way too many founders focus on the technology, whereas they need to realize that the actual focus is on selling it. So in terms of funding, you need to reserve a very solid chunk for sales and marketing.
Interesting. So just a quick question for you before we move on is were you, so in your startup that you did, were you the technical founder or the business founder?
I was the technical founder.
Right. Because the way you were talking, you sounded like the business founder. That's all. Because
yes, I mean, I attempt to learn. So there's some artificial intelligence that that tries to learn over time. And I started in the mindset that I'm describing, right? The important thing is the product. I have to be better than everybody else. It has to be, efficient and high accuracy and so on. And I learned over the time that that's completely untrue. Yeah, my product can be inferior in many senses and be more successful. And the key, so if you have a great product, you have a great product. You don't have a business yet. Only if you're able to sell whatever it is that you have, do you have a great business. And there are some really crappy products that make a great business. So if you plan to, pay your bills with your startup business, the key is sales. And this is something I didn't know at the beginning. I had to learn the hard way.
Right.
But now that I know it, I can tell other people that is the key. The technology is not the key. The key is sales.
Well, there's two classic things. There's classic phrases. I think you've probably heard before. Is like build it and they will come. Yeah.
Right.
Yeah.
That's almost never turned out to be.
And then the second one is sales solves all known problems.
Yeah.
So yeah.
Yeah,
that's good. That's good to hear.
As unfortunate as it is for us techie people, that is mostly true.
That's fascinating. Well, I mean, Matt, you see, the thing is, I started off in a technical track, and then I've kind of done more commercial stuff as I've got older.
Yeah.
But actually having a good technical base, when you get into this type of area, is incredibly useful. Yeah. It's you become more rounded, and you look at it through different lenses. So I think that's the thing that I would, I've worked in Silicon Valley a couple of times personally, and it's an interesting place to be.
It is definitely very interesting.
There's always something going on.
Yes, very dynamic.
So if you talk, so you talked about your G piece, and it's. I was going to say, you said you were originally from Germany. Whereabouts in Germany were you actually originally from? Was it whereabouts in Germany were you from?
I was born in the south, in Tübingen, near Stuttgart.
Oh, near Stuttgart. Okay. Oh, fantastic.
Yeah.
Big Siemens headquarters kind of place, that isn't it?
Yes.
Yeah.
Yes.
Yeah, I've been there quite a few times. It's been quite an interesting place. It's good beer. It's good Weiss beer. So on the T side, the tech side. So I know you explained quite a bit about that. It sounds like you kind of, did you just fall into technology, or what was the trigger to get involved in tech? Because obviously you've obviously got a very, very good, amazing background. But was there something happened earlier in your life that triggered that interest, or was it just that you were always interested in? I think you said you were interested in the physical world. What was the?
Yeah. I was always interested in the physical world. So, as early as I can remember, my dad used to have astronomy books lying around. And so that became my first interest. I think as a 5 or 6 year old, I might have wanted to be an astronaut.
Oh, wow. Okay.
That's a sign of the times, of course. And back then was all the big astrophysics, astronomy projects going on in the public view. And so I wanted to figure out how the world works, how does stars work, why are galaxies like this? And so that's why I ended up taking a physics degree. And there you quickly find that there are two kinds of physicists: the experimental people who do measurements in the laboratory, possibly a very large laboratory like CERN in Geneva.
Yeah.
And then there are the theoreticians who do some work on paper, but most of what they end up doing these days is on the computer, writing computer programs to solve differential equations and figure out what's going on. And the progress is really the conversation between these two groups. Right? Sometimes the theorists are a little ahead, sometimes the experimentalists are a little ahead, and they talk to each other, and that's how physics progresses as a field.
Right.
So I find that absolutely fascinating.
Like the tension between those two groups, is that what you're saying?
Right. So when I got involved in this at at the level of being a PhD student, there were a number of artificial technologies already available. The neural network was available and things like this. That's a fantastic tool to solve many problems. And so I got interested in, how can we use this? I learned programming languages, of course, as you do in these kinds of university studies. And so I drifted off more and more into this kind of modeling stage. And artificial intelligence comes naturally at that point. So I got involved in artificial intelligence quite early on. And it's been a very interesting journey ever since. The field has developed slowly. In the last few years, of course, it's somehow become very famous.
Yes.
So somehow the field has managed to rebrand itself with a new little title. It's called deep learning now.
Right. Yeah.
There are, of course, a couple of twists that make it different than what it was before, but I think the true innovation in the field really has been pushed by computing power on the one hand and the availability of large data sets on the other hand.
Right.
There are, of course, mathematical ideas that are new. And so all of these three things put together have created a number of successes that have been, very public facing. Of course, accomplishments like being able to beat a chess or a Go champion. There are very public facing achievements. Those are, of course, not commercially relevant, but they're very, very impressive that push the field forwards. And there are now very many commercially relevant use cases that artificial intelligence can support. So all of that is, of course, a tremendously exciting journey, and I'm very grateful to be a part of that.
It's interesting because if you think about I was just thinking when you were talking about astronomy, it was like I was thinking about Magnus Pike. You remember Magnus Pike?
Right.
The kind of crazy kind of, and then also thinking about, I suppose if you think about like Alan Turing, he wasn't really, he wasn't kind of in the people's awareness, and I don't know whether that awareness has gone up since the kind of the famous film with Dominic Cumberbatch. Yeah, suddenly he becomes, his backstory, and obviously with all the things he went through, his challenges. But yet the stuff he did with the Enigma machine and the stuff he did there was around the war, which was, which is kind of like doing, that thing in that, what was it, kind of Hut 8, wasn't it? I think in place in just north of London. All that kind of stuff is now in the more people's awareness of it, of what that was working on, and that's 80 years ago. Yeah, it's kind of quite amazing. Or it's just. It becomes in people's consciousness. That's what I'm sort of going to say. It's more well known.
Absolutely. I mean, the work that they did at Bletchley Park is absolutely amazing. They had a very concrete, practical problem. Right, every morning you have to crack the new Enigma code.
Yeah.
And on the back of that, Alan Turing and the people in his team developed a number of really, really amazing things, a number of theoretical results that are absolutely underpinning computer science, not just artificial intelligence, but computer science as a whole was basically founded at that time. And on the other hand, they actually built physical machinery that did the solving. So not only did he invent computer science, he invented computers.
Yeah.
And this was done in the backdrop of a very hurried, everyday solution program to a problem to save lives.
Yeah.
So here you can see that, a practical problem combined with time pressure, combined with a virtually unlimited financial budget, of course, that the military had, can lead to some absolutely amazing
breakthroughs. Yeah. But it's hardware. He created hardware and software, didn't he? So that's
he did.
What he was doing. Yeah. So, amazing. So in terms of, if you're looking like forward, if you look, you talked about your backstory, you talked about some of the things you've learned. In obviously you transitioned from a kind of a startup environment back into, you could say, if you come from an academia to startup and then into a very multinational global. I don't know, would you call Samsung a tech company these days, or what would you call it?
Yes, of course, it is. I mean, the most famous products of Samsung are mobile phones, TVs, and displays, and those are technology.
Actually, I was using one of my friends. Actually, was I can't remember what the model's called, but he brought one of the Samsung mobile devices. The folding one.
Yes, the new one.
The folding screen. Unbelievable! I could not believe. I was like, it's like an eye. It was like there was no line in it at all.
Yeah,
you can't tell. And I go, I've just folded up a screen and then brought it back, and it's like, what? No line. It was just like a. I'm not supposed to say it's like an iPad. It was like obviously like a note tab, a tablet.
Yeah.
but just absolutely amazing, absolutely amazing. So, and obviously,
yeah.
that's like the displays of the future, I suppose, isn't it? When you can fold screens in half. I know that they predicted it a while ago, but you've actually done it now. So fantastic.
Yeah, there's some amazing hardware developments like that. On the software side, Samsung SDS is doing similar things in the field of artificial intelligence, where we're really pushing the boundary of training.
That's your kind of one of your differentiators, because I suppose there's quite a lot of. So I was down in Amazon do a AWS summit. They did it in London a few years ago, and Werner Vogels, who's the CTO of Amazon, was presenting, and he must have spent 90% of his keynote talking about machine learning and AI. So,
yes.
It was, he's obviously, there's some interesting use cases that Amazon are using, but it just shows how important that topic is becoming to the future of tech and the future of the how you use it for practical purposes, I suppose. That links to
absolutely.
That's what it links to kind of one of my next questions was about. You've come into now into, you could say, back into a large corporate organization. If you think about your history and your backstory, what are your dreams for the work you're working on now? We're now in 2020. What are the dreams you've got for the next 5-10 years? Any thought on that?
Well, as far as the Samsung SDS story is concerned, the goal here is to really drive adoption of some of these technologies to accelerate training, to make that better, to bring some of these automated machine learning tools into practical use, and to drive that as widely as we can in order to enable as many use cases out there as possible. I think, if we talk about end use cases, some of the more practical things are in healthcare. Of course, autonomous vehicles also as a specific application, but the use cases are there, and they require some of these technologies to accelerate training because we're looking at very large data sets. Right. Nowadays, getting the data has become a lot easier. Dealing with the data is the kind of new bottleneck, and that's our core offering at Samsung SDS to solve that bottleneck problem.
Right.
So that's our focus for the next few years, to help other companies who own the data solve that problem with our tool set, so that we can get accurate models quickly. And provide them in the application. So of course, then there are the technological aspects. You need to then take the model out of your data center and put it on the edge. That's of course another really new topic, right? The edge. You want to be able to provide the models in such a way that they can run on a resource constrained, very small chipset that lives on a device, let's say inside the car, for example, or inside your X-ray machine. And another part is deployment. So let's say you have 1,000 X-ray machines in hospitals around the world, and you update your model, right? You want to be able to automatically deploy that model to all of those 1,000 X-ray machines without having to work really hard at it. You don't want to have to ship out a CD by the mail to each one of these people. You want internet connectivity so that you can automatically deploy to the site and get feedback from there, right? So that you can collect more data automatically, make the model better again, and suddenly you're in a loop, right?
Yeah.
New model goes, new data is brought back, new model is made and deployed, and the loop continues, and we're getting ever better and better at recognizing cancer, at diagnosing COVID, for example. Right? It's recently become possible, looking at a lung X-ray to detect whether or not you have COVID.
All right.
So things like this, medical imaging is tremendous. Autonomous vehicles, as I said, tremendous. There are some other big industrial applications. And then to close a really, really big loop, I think this can contribute very significantly to solving climate change.
Okay. Well, because of the kind of the full life cycle, the kind of the feedback loops you're saying?
Well, the feedback loop makes the models better over time, no matter what the use case. But in terms of climate change, of course, you're looking at very many technologies having to work together. So you have to push the alternative energy fuels like solar, like wind, like water power. You have to make sure that they work together correctly in the grid to be able to supply power at an even rate. Yeah, we don't want to be able to use the laptop only when the sun shines.
Yeah.
But it has to be continuous, and for that you have to have various buffer mechanisms that require some form of intelligence. The new innovation that's needed but not here yet is an efficient battery system that will store electricity at scale. Artificial intelligence has made some advances in material science, where we design new compounds, where we design new machineries, where we attain a very significant speed up on solving physics problems. Right, so just solving partial differential equations used to be a time-consuming iterative process. Nowadays, neural networks can solve partial differential equations in a fraction of the time.
Right.
So instead of having slow solutions that take time, you can now solve them in real time, which means you can operate these technologies much better. You can create new ones. So a whole range of problems can be solved. And of course, there's no denying climate change is the one challenge of our generation. So as long as we have the momentum, AI can contribute very significantly to that.
And what, I mean, climate change is a huge topic. We could spend probably a whole episode talking about climate change. But I mean, if you're going to describe the kind of key top areas that the use cases or the kind of the capability that you're seeing could help climate change, how would you describe that?
Well, as I said, one of the primary things is the energy transition to go from a carbon-based energy production through coal, oil, and gas towards a renewable production.
Right. Yeah.
And one of the major differences between the two is that the renewables are unpredictable. So you need to be able to predict, when does the sun shine, when will the wind blow,
right?
If I have a tidal power, when are the waves going to come? Then I need to negotiate between these things. So in Europe, for example, right? If it's cloudy in the UK but it's sunny in Spain, can I redirect my electrical grid in such a way that the power coming from Spain and the absence of power coming from the UK, can they somehow even out?
Right. Okay.
Without me having to turn on the gas power plant down the road.
Right. Okay. So like automatic reallocation or that was the key thing you just said there was predicting, because if you can use the machine to help you predict based on data patterns and based on extrapolation of what it looks like is going to happen. predictive.
Yeah, you need forecasting, exactly. You need the optimization. How do I reroute things? When do I call on whom to either produce or stop producing? So part of this is called the smart grid.
Yeah.
But it then comes back to the operators, and then you're looking at predictive maintenance for all this equipment. So a lot of these things, plus of course the kind of material science engineering type innovations to make new technologies, especially the battery. Lithium ion batteries are not capable of providing the kind of energy buffer that we actually need. Even if we wanted to, there isn't enough lithium and cobalt in the world to do it.
Right.
And then they last for a few years, and the end product is toxic. That's no good. So we need a new kind of battery that we don't have yet.
Right.
And AI can contribute to that. So there's a whole bunch of aspects.
Looks like you're going to be busy.
Yes. Of course. So there's a lot of potential.
Actually, it's going to be busy for at least the next 10, 20 years.
There's definitely a lot of potential that AI can help, humanity and the journey forward in all sorts of technologies. Yeah. But I and my department, we're definitely going to be focused on the training element of AI. So how to make models quickly. One aspect just earlier this week, this new GPT-3 language model was released. And training it once cost $4.6 million. Right? So let that sink in.
Oh my God.
Yeah, the amount of computer hardware and electricity that was consumed in training that natural language model once is several $1 million. So you can see by that example, training AI models is a significant task.
Yeah.
And if you can do it faster, if you can do it cheaper, and thereby enable a more accurate model to come out the other end, is a significant contribution. And that's where Samsung SDS sees itself as the kind of intermediary between the people who own the data and the people who are going to apply the AI model later on. We're the guys who train it.
Yeah, no, I think you spot on with that positioning, because actually there's all these people that are saying, oh, my cloud, my cloud, my cloud, my cloud. You go, okay, we've got the data in the cloud, right? Job done.
Yeah.
What's next? Oh, we've got to train the model now. Okay. See you in a while. And the business is going, please give me the answer. Please give me the answer.
Yes.
Interesting.
So everybody's talking about digitization.
Yes.
And to most people, digitization means getting numbers in a file on a cloud server. Yes. And then, we're done with digitization, right?
Put the tools down now. We can go to the pub now. Yeah.
Yeah. You're not done. You've just started. Yeah. Now you can do things with the data. Before you didn't have it. Now you have it. But just having the data is no accomplishment yet.
I suppose a quick question on that was that obviously I presume as part of your role, you would define the strategy of this whole piece as well. But I suppose from your personal experience in academia, and obviously then the startup experience you've got, you saw this was the bottleneck. Was that your kind of light bulb moment, or was Samsung already working on that? Is that something you brought into Samsung, or?
Samsung was already working on that.
Okay, they already identified it. Yeah.
The fact that this is the bottleneck isn't really my brilliant idea. I think it's apparent to everybody who works in this field that I think training is significant.
I think Patrick came up with it. You heard it here first on the GNC Sessions podcast.
Yes.
No, but I suppose what you're saying is you can have a strategy, but then it's how you execute on that strategy into it. Then that's what makes a success. So.
Of course. I mean, it's one of my statements. Ideas are cheap. Many people have many really good ideas, but ideas mean nothing unless you execute on them. And it's the execution that requires time, sweat, blood, and money. And that's what really counts, because on the back of execution do you get results.
Yeah, spot on, bullseye. Okay, so I mean, in terms of just kind of wrapping up with today's session, given you've actually been, you've been in quite a few areas. Some people who come on this podcast have just purely been in startups. People who in corporates. I suppose the thing is about some of your lessons, and takeaways. I suppose for people who are listening to this episode, what would be your advice to your younger self, or what would be some takeaways that you can share that people think about and reflect on after listening to this episode?
I really liked being an entrepreneur. It's a nice thing. And if you go to a corporate structure where you are, let's say, sufficiently high in the food chain, then it's quite like being an entrepreneur on your own. So it's not too different. The two things, as I said, to watch out for is, who are your partners in this? For the startup, your co-founders. In the corporate, who are the other people who are either above you or on your level? Who do you have to talk to every day to get permission to do this and that? Having the right people is very, very important. Of course, in both senses, you need to be a team player. Yeah, so the central statement is the same statement as the military: we don't leave our people behind. If you're the kind of person who leaves people behind, then you're in trouble, no matter whether you're an entrepreneur or a corporate guy.
Yeah.
The second thing is, of course, funding. The startup typically suffers from having no funding and having to go to venture capitalists to get the funding. In the corporate, this is the yearly budgeting cycle.
Yes.
But it amounts to something quite similar, in the sense that you have to ask for a certain amount of money in order to do certain things. You have to justify that ahead of time. You have to justify that after you're done. So it's not altogether that different from running a startup with the VC funding when you're running a corporate department that requires funding from C-level.
Yes, so it's part of your 1 or 3 year plan, I suppose, isn't it? So you've got to, you may have a 3 year plan, but then you draw it down every 12 months or whatever.
Yeah, of course. And it needs to be modified every so often. So at least in software development, which is where we are, we typically run on the agile model, which means there's a redesign every 2 weeks.
Right. Yeah, the sprint.
Yeah.
Make sure you've got the right stuff on the backlog and make sure you prioritize the right stuff. Yeah, exactly.
Yes. So the agile methodology is absolutely key to, I think, developing new technologies, especially software type technologies.
It's nearly 20 years old, though, Agile now. The Agile Manifesto is 20 years old. I think it's next year, I think it is. So it's quite scary.
Yeah, but it's totally relevant. I mean, at the end of the day, all it's saying is pay attention to your customer, involve him in the feedback loop as soon and as frequently as you possibly can. And don't worry about defining all the criteria a year ahead of time. That just doesn't work.
Yeah, I suppose what my experience has been is probably, I don't know if you've experienced it as well, but where people who are not as aware of the adoption, the ways of working. Some people want to have real black and white, and this thing about grayness. It's like, ooh, what you mean you don't know what you're going to do for the next 2 weeks? Well, we kind of do. It's very interesting. I suppose it's thinking on the, because obviously you've got more of a tech history, and I suppose as you become more on the business side, then I've obviously noticed some interesting behaviours and people, fear, uncertainty, and doubt.
Yes. I mean, part of the uncertainty is this grayness that you describe is absolutely right. The other aspect is that projects tend to be a moving target. So not only is my target not in black and white, but in gray, but it's also moving.
One of my other guests, actually, Alan Kelly, who came on the show a few months ago, he he's actually written I think it's 9 books now, I think, something like that. And one of his books is called Continuous Digital. Is what he says is it's continuous everything. Yeah. You know, so, and he actually is one of the leaders of the No Projects movement. So hashtag No Projects, because basically what you find is people are continually, you know, you're releasing things, you're making things available for the business or for technology all the time. So, you know, why do you start, run, stop, and then start, run, stop? Why do you just continually just do things? So, but then it obviously has some ramifications. One of the telcos I worked for had this thing called water scrumfall.
Okay.
Which was basically waterfall, and trying to do waterfall and agile at the same time. Yeah. So they basically, it takes so long to get money out of the finance team. It was like a waterfall project. Yeah. Then because you were starting late, you had to run like hell. Yeah. Quick, let's try and get the development stuff. Right? Quick. Yeah. And then because the deployment into production was like, oh, that's risk. Yeah, that's risk. Or we're going to do it really meticulously. Yeah. Let's do that back to waterfall. And they're going, what? So yeah, it's definitely hearts and minds. Yeah. So
yeah, that sounds very curious.
Yes, if you hear of a project saying doing water scrumfall, then please run away. Yeah, exactly. Run in the direction. So, I was just going to say thank you so much for coming on today's show. Fantastic episode, Patrick.
Thank you, Andrew, for inviting me.
No, it's an absolute pleasure. Thank you. There's some great one-liners out of today's show, actually, that I think we both shared and both triggered in the conversation.
Yeah.
So that was Patrick Bangert, who's the VP of Artificial Intelligence at Samsung SDS, based in lovely California. He's probably got, you're going to get his shorts on now and go out on the beach and go surfing.
Right.
Obviously, I've got the beach behind me, but it's nowhere near the beach in London. But anyway. And thank you for coming on the show and have a wonderful day. Thank you.
Thank you very much, Andrew.